In this video, we are going to solve problems on electric field. Here it says the figure below shows a region of uniform electric field of magnitude E equal 100 Newton per coulomb. And then we have got a diagram in which they are also showing a negative charge of negative 8 nanocoulomb kept in the electric field. The question is asking calculate the magnitude of electric force exerted on a negative 8 nanocoulomb charge placed in the electric field. So we want to find the force. They gave us the charge which is negative 8 nanocoulomb. We convert that into coulombs by multiplying by 10 to the power negative 9. The force is missing. Electric field is given. So we use the formula E equal F over Q. We arrange the formula F equal Q times E. And then we have got the numbers. We get the answer as negative 8 times 10 to the power negative 7 Newton. Because we are calculating force, so the unit will be Newton. But because the question is just asking for magnitude, so we'll remove the negative and the magnitude of force will become 8 times 10 to the power negative 7 Newton. Next is asking on the figure above, show with an arrow the direction of electric force on negative 8 nanocoulomb charge. So they want to know how this charge will move in the electric field. So what we will do is first, you know that electric field goes from positive to negative. So let's just write that positive will be on the left side and negative will be on the right side, because that's how the electric field direction is shown, from positive to negative. Then we have got a negative charge. Obviously the negative charge will get attracted to the positive. So the force on the negative charge will be to the left as shown in the diagram, and we'll just label that as F. The next one, if the negative charge is now replaced by a positive charge of same magnitude, what is the new force on the charge? So we had a negative charge, we replaced that by positive charge, but the magnitude of the charge is same. That means it is now plus 8 nanocoulomb. So our force magnitude will also remain same because the number did not change, but because it's a positive charge, it will move opposite to what negative charge was doing. So if negative is moving to the left, the positive will move to the right. So we have to select an option here. The magnitude stays same, but the direction will be opposite. Next, let's check one more problem on electric field and charge in the electric field. Here we have got a proton which is released in uniform electric field. Describe the motion of a proton after it is released. Now, proton is a positively charged particle. So any positively charged particle will move along the direction of the electric field. So the answer will be proton will move along the direction of the electric field. Next is asking you for electron. That means instead of proton, if we use electron. Electron is a negatively charged particle. So if proton moves along the direction of electric field, a negative charge, that is electron, will move opposite to the direction of electric field. Here we have got an electric field in the atmosphere is about 150 Newton per coulomb downward. So that means electric field will be negative 115 Newton per coulomb, negative because it's pointing downwards. So we can draw the electric field lines pointing downwards, and then it says what is the direction of force on a negatively charged particle. So if we keep a negative charged particle in this field, how will it move? So already we said in the previous slide that negative charges move opposite to the direction of electric field. So if electric field is downward, the negative charge will move upward. Then it's asking you to find the electric force on the electron, and the charge is given to us. So we know the formula is QE, we already used it. We substitute the numbers. You can see that electric field is negative 150 and the charge on electron will be negative because electron is negatively charged, and we get the answer as 2.4 times 10 to the power negative 17. The unit will be Newton. So let's just put the unit there. Unit will be Newton, and it will be acting upwards as we discussed in the previous problem, that is part A. What's the direction of the motion of the negative charge? Upwards. So the force will be acting upwards. Now here we have got electric field the electric field 0.25 meter away from point charge. So meter, that means that's the value for R. So this is different from the previous problem. In the previous problem, there were no r's. That is, there is no distance from a point charge. So here we have got r, which is 0.25, and the electric field is given as 9.4 times 10 to the power 5. How do I know it's the electric field? We can read the question, or we can look at the unit, Newton per coulomb. So that's electric field. What is the magnitude of the charge? So we want to find what's q. The formula which we'll use is E equal kq over r square. K is a constant, we know it, and all the other numbers we have got in the problem. We solve it using our calculator. We get the answer as 6.5 times 10 to the power of negative 6 coulomb.